When NASA launched the James Webb Space Telescope on Christmas Day 2021, the goal was simple, yet profoundly arrogant. Humanity wanted to look back in time. We built a $10 billion time machine, designed to capture the faint, stretched light of the very first stars flickering on after the Big Bang, and finally confirm the origin story of our reality. It was supposed to be a victory lap for modern science, the final piece of a puzzle we had been assembling for a century. We thought we knew the timeline. We thought we understood how the cosmos grew from a chaotic, hot soup of primordial particles into the majestic, structured spirals and ellipticals that fill the night sky today. We had models, we had simulations, and they all agreed. But when the first data from the absolute edge of time arrived back on Earth, the celebration in the control rooms stopped dead. The data didn't match the models. In fact, it didn't even make sense. Instead of finding the tiny, chaotic, messy baby galaxies that our theories predicted, James Webb found monsters waiting in the dark, deep in the primordial vacuum, just a few 100 million years after the universe began. The telescope's sensors detected massive, fully formed, incredibly bright galaxies that simply should not exist. According to everything we know about physics, gravity, and cosmology, there wasn't enough time for them to grow. It's the cosmic equivalent of walking into a hospital nursery and finding a fully grown adult man sitting in a crib, wearing a suit, reading a newspaper. It defies the fundamental laws of growth and causality. And this discovery has sent a shockwave through the scientific community that is still vibrating today, causing panic in university halls and observatories around the world. Some astronomers are now whispering the unthinkable, that our standard model of the universe, the very foundation of how we understand reality from the atom to the supercluster, might be fundamentally broken. This is the story of the impossible galaxies, and why the history of our universe might need to be rewritten from page one. To understand why this is so terrifying to scientists, we have to look at the timeline we've accepted as gospel for decades. The standard model of cosmology, often called lambda CDM, says that the universe began with the Big Bang about 13.8 billion years ago. In that fraction of a second, everything that ever was compressed into a point of infinite heat and density. As space itself expanded and cooled, this energy coalesced into simple hydrogen and helium. Then the universe entered what astronomers call the cosmic dark ages. For hundreds of millions of years, there was no light. Just endless, expanding clouds of neutral gas in total blackness. It was a silent, empty epoch. Slowly, agonizingly slowly, gravity began its work. It started to pull clumps of dark matter and gas together in the dark. Our best supercomputer simulations showed us that this process takes immense amounts of time. It takes eons for the first stars to ignite, burning off the fog. It takes billions of years for those first chaotic clusters of stars to merge, to feed, to organize themselves into rotating disks, and finally become the massive, structured galaxies like our own Milky Way. You don't get a galaxy like ours overnight. It's a construction project that requires billions of years of cosmic labor. So when scientists pointed James Webb's giant, gold-coated beryllium mirrors at patches of seemingly empty sky, aiming for that cosmic dawn, the era when the lights first turned on, they knew what to expect. They expected to see faint, messy, irregular blobs of light, the precursors to galaxies, little cosmic wrecks. Instead, they saw 6 massive, distinct red dots shining back at them from the abyss. To understand what they were seeing, you have to understand how Webb works. It doesn't see light like your eyes do. It sees infrared heat. As light travels through the expanding universe for billions of years, it gets stretched out. High-energy ultraviolet light from infant stars gets stretched all the way down into the red and infrared spectrum by the time it reaches us. The redder the dot, the older and farther away it is. When astronomers analyzed the light from these 6 specific dots, the redshift numbers came back impossible. These objects, quickly dubbed the universe breakers, were estimated to be almost as massive as our own Milky Way, containing tens of billions of solar masses. But here is the kicker. They existed when the universe was only roughly 500 million years old. That's barely 3% of its current age. Imagine building the entire city of New York, from the bedrock to the top of the Empire State Building, in 10 minutes. That is the scale of the anomaly Webb discovered. To create that many stars that quickly, these galaxies would have had to convert almost 100% of their available gas into stars with perfect efficiency, instantly, without stopping. That doesn't happen in nature. Star formation is messy. It is violent. Supernovae explode and push gas away, stopping new stars from forming. Nature is inefficient. These galaxies were breaking the speed limit of physics. This leaves scientists staring at two very uncomfortable options, and neither feels good. Option 1. Our understanding of astrophysics, how gas collapses to form stars and galaxies, is completely wrong. Maybe there is some exotic mechanism in the early universe we don't know about, some hyper-efficient way to build stars that we missed. Maybe magnetic fields or turbulence behaved differently back then. Option 2 is far more radical and terrifying. Our understanding of the universe's age, or its expansion rate, or the Big Bang itself, is deeply flawed. If the timeline is wrong, then everything we measure is based on a broken ruler, and the evidence keeps piling up, making the flawed timeline theory uncomfortably plausible. It's not just the sheer size of these galaxies, it's their chemical maturity. James Webb has spectrographs on board, instruments that can split incoming light into a rainbow to analyze its chemical composition. We know that the very first stars should be pure, just hydrogen and helium left over from the Big Bang. Heavier elements, what astronomers call metals, things like oxygen, carbon, and iron, are forged only in the crushing hearts of dying stars and then blasted out into space when those stars explode. It takes generations of stars living and dying to enrich the universe with metals. In the very early universe, there simply shouldn't be much metal, because there hasn't been enough time for the first generation of stars to die yet. But when Webb analyzed the light from some of these impossible galaxies, it found strong signatures of oxygen and other heavy elements. It's another fingerprint that doesn't fit the suspect. It suggests these objects had already gone through generations of stellar evolution. They looked old when the universe was supposed to be brand new. This crisis has reignited debates that many thought were settled 50 years ago. The panic behind the scenes was palpable. In the months following the first data release, the Arcasov preprint server, where scientists upload papers before peer review, was flooded with desperate attempts to explain away the monsters. Some suggested dust was messing up the readings. Others suggested the galaxies weren't big, just incredibly bright due to strange black hole activity. But as the calibration improved, the signal remained. Some radical new theories, fueled by this Webb data, are now gaining traction on the fringes. One suggests the universe could be twice as old as we think, perhaps 26 billion years old, based on tired light theories that were discarded decades ago. If you stretch the timeline that much, the monsters make sense. They had time to grow. But if you do that, you break almost every other measurement we have from the cosmic microwave background radiation. It's a scientific house of cards. You pull one card to fix the galaxies, and the entire structure of cosmology threatens to collapse. Other theorists are desperately proposing things like early dark energy, a mysterious force that might have accelerated the universe's expansion differently in the distant past, creating a mirage in the data. And we haven't even talked about the black holes yet. At the center of nearly every massive galaxy sits a supermassive black hole. For a long time we faced the chicken and egg problem. Which came first, the galaxy or the hole? Webb is finding black holes in the early universe that are also way too big, way too early. Some are millions of times the mass of the Sun, existing when the universe was a mere toddler. There is a physical limit to how fast a black hole can eat matter, known as the Eddington limit. If it eats faster than that, the outward radiation pressure blows the food away. These early black holes seem to have ignored this cosmic speed limit entirely. Did they form from direct collapse? Giant clouds of pristine gas collapsing straight into a massive hole without ever becoming a star? If so, the early universe was a far more violent, terrifying, and dark place than our simulations ever imagined. The implications of this go beyond just astronomy. They touch on our place in reality. We build our philosophy and our science on the idea of uniformity, that the laws of physics we observe today on Earth are the same laws that applied 13 billion years ago at the edge of nothingness. We believe we can observe the past to predict the future. But if we are looking at the edge of observable reality and seeing gigantic structures that violate our best models, it reminds us how little we actually know. We are like ants standing on a single leaf, thinking we understand the entire forest. James Webb has acted like a high-powered flashlight turned on in a pitch-black room. And the first thing it revealed was that the room is shaped differently than we thought, and it's full of things we didn't know were there. Critics and skeptics are still scrambling to find errors in the data. Science is, after all, a process of correction. Maybe the models of stellar light are wrong, they say, and that is possible. But as more data streams in from Webb every week, the signal isn't going away. The monsters are still there, more of them are being found. We are now finding disk galaxies, orderly, beautiful rotating spirals like our own, at time periods where everything should be chaotic wreckage and violent mergers. It's too neat, it's too fast, it's too big. What if the universe didn't start with a bang but something else? What if the fundamental constants of nature, the speed of light, the strength of gravity, have not been constant over billions of years? These are the questions being whispered in high-level conferences now. Questions that were considered fringe pseudoscience just 5 years ago are now sitting center stage. All because some gold-plated mirrors a million miles away from Earth took a picture of a few red dots in the void. There is a palpable sense of excitement in the scientific community, but it is mixed with deep anxiety. Because if the standard model of cosmology falls, we are drifting without a map. We have to rebuild our history of the cosmos from scratch. And while that is exciting for a young astrophysicist looking to make a name for themselves, it is deeply unsettling for a species that craves certainty. We want to know where we came from. We want the story to make sense. Right now, the story does not make sense. The James Webb Telescope is still just warming up. It has decades of fuel left. It will look deeper, stare longer, and see clearer. And if the very first year of operations has already threatened to break cosmology, what will the next 10 years do? We might find that these impossible galaxies are just the tip of the iceberg. We might find evidence of stars powered by dark matter annihilation. We might look back so far that we see the moment the lights turned on, only to realize the switch wasn't where we thought it was. We are living through a scientific revolution in real time. History books will almost certainly be rewritten in the next decade because of what is happening right now. The Big Bang chapter might get a lot more complicated, or it might get torn out entirely. And perhaps that is the beauty of this moment. We built the most sophisticated machine in human history to confirm what we already knew, and the universe paid us the ultimate compliment. It told us we were wrong. It gave us a new mystery. So, the next time you look up at the night sky, remember that the light hitting your eyes is just the local news. The real action, the terrifying secret of how this all began, is hiding in the deep infrared, in the dark spaces where human eyes can't go. There are monsters in that dark. Giants that grew too fast, ancient structures that defy time itself, and they are waiting for us to figure out how they cheated the rules. Or maybe, just maybe, they are waiting to teach us that the rules were never what we thought they were. The universe is not just stranger than we suppose. It is stranger than we can suppose. And James Webb is just getting started.